Hello, everybody. Welcome, and thank you for turning on the first episode of our new Bosch Thermotechnology Expert Talks. Today, our topic will be hydrogen in the heat market. And we currently have around about 200 participants online. Thanks a lot for that. Oh, it's 230 already. Thanks a lot for joining. My name is Thomas Pelliceus, and it is my pleasure to guide you through the event. But let me start with a few words about the idea behind this new series. With annual sales of around about 3.5 billion euros, Bosch Termotehnică is one of the major international suppliers of HVAC systems. We offer solutions for indoor climate, domestic hot water, and decentralized energy management. We provide highly efficient technologies, many of which use renewable energies and make an important contribution to reaching climate targets. At the same time, we deal intensively with the enormous changes that the building sector and the heating market are facing on the way to climate neutrality. In the expert talks, we will give you an insight into our ideas on these changes and discuss them with you. Therefore, we would like to invite you to enter questions in the chat window to the right. We will have a short time after each keynote for 1 or 2 related questions. And in addition, we have reserved time at the end of the session for further questions. 2 technical remarks. I would like to point out that the whole session will be recorded. And if you have any technical problems, try to reload the page by pressing F5 on your keyboard. That helps in most cases. Well, today we will have a closer look at hydrogen in the heat market. From our point of view, using hydrogen in heating applications is one of the cornerstones to reach the climate targets in the building sector. We would like to underline this opinion in the following 3 keynotes. First, Philipp Woerner, our hydrogen coordinator, will speak about the European Green Deal and the role of hydrogen within the process of decarbonizing the heat market and Bosch Thermotechnology's strategy. Tom Collins, our head of hydrogen program, will share up-to-date insights on our hydrogen-ready boiler as an application for residential buildings. And Daniel Gosse, head of the Industrial Boiler Academy, will speak about the commercial and industrial application of hydrogen. But let's have a start now. I wish you some interesting insights and a fruitful discussion, and I'm happy to give the floor to Philipp Woerner. Please go ahead.
A very warm welcome from my side. So, just need to start this, sorry. You have to help me now. Do you see the right screen now?
We do not see the presentation view, but I think it's okay. I can read it.
Because I lost my mouse. That's very sorry for that. So now it works. Yeah, I'm having the pleasure today to give you a little introduction into the role of the green gas within the process of the defossilization of the heating market and our special corporate strategy on it. Yeah. Let me start you with the current Green Deal target line. Yeah. On the screen, you see now the current enacted target, what was enacted in the European Commission from currently -40% to now -55% in terms of the CO2 emission reduction compared to the emissions of 1990. This new target setting has a significant effect, especially to the individual sector targets. In the middle, you can see the new target setting now for the industrial and also for the residential segment. Yeah? And this means that the current activities, as we have it defined for the new build and also for the renovation of existing building, needs not only to be massively increased, now it needs also to be accelerated at the same time. Next to massive speed, yeah, in the expansion of the capacity and of the electrical grid, yeah, and of the demand to cope with the demands of the space heating, industrial applications, and also mobility. Green gases, especially such as green hydrogen here, having a great opportunity as a second energy carrier to be an active contributor in the decarbonization pathway. Yeah. Why? Renewable gases, such as hydrogen, can be used to decarbonize existing buildings, to enable an optimized use of the existing energy infrastructure. And we are able to offer plug-in replacement solution, especially for the renovation of old buildings. Next to that, the repurposing of the existing gas infrastructure, and here we're speaking not only about the end use, it's also transport, it's also distribution and storage to green hydrogen. It offers a great opportunity to soften the electrical grid strain, especially on times where there is low wind and sun. On this slide, I want to give you a little overview. How can we make use of green hydrogen or green gases within our industry? But let's start from the left to the right, and then I guide you through. The scenario A is the most simple one. You take the green hydrogen or the available hydrogen and just mix it kind of like a cocktail in the existing gas grid. Over the time, you can then increase the share of synthetic gases and biomethane plus the hydrogen, and we're getting more and more carbon-free. The great advantage here is we can use the existing combustion technology and certify them against the new gas quality. In the scenario B, we speak about so-called hydrogen islands. Here, the topic is that a successive upgrade of the existing gas grid sections will take place to local hydrogen nets. Over the time, these islands are then increased and enlarged step by step until we have a fully CO2-free area, and then later on as well the full market. The key challenge here is, of course, that you have to absolutely synchronize to the same moment the hydrogen supply, so the availability, and also the gas end-use installation at the same time. So everything has to be prepared together. And last but not least, we have here the scenario C. This is the so-called hydrogen-ready scenario. And there, this is very important, the appliances are new technology, and therefore they are designed and released especially for the combustion of pure hydrogen. But when they are installed in the field, they are converted to natural gas setting. The great advantage here is you have time for the grid and for the hydrogen supply to be step by step phased up, ramped up. And then when there is the hydrogen available in front of the door and the installed stock is prepared to hydrogen readiness, these boilers are simply switched. Nevertheless, in all of these three scenarios, there's currently no clear winner yet in Europe. That's why we as Bosch Thermotechnology will offer for all of the three scenarios the right products and right time. Let me show you now with this picture actually what plans we are following. You see on the upper left corner here the path of the blending, so mainly the scenario A. Here I'm happy to tell you that even our installed products today, when they are younger than 1995, are already able to work with up to 10% of hydrogen blends. So you can start decarbonization already from today onwards. Our modern combustion technologies are now in the next step certified for 20% of hydrogen blends. So this means our next generation of products will be certified for those 20% of hydrogen. Next to that, we will follow in parallel the path of the pure hydrogen. Here you see directly a difference in the countries. And yes, this is right. UK is here a little bit ahead than the rest of Europe. And this is mainly the topic that here is a huge interest based on the availability of the electrical grid and also the capacity of the grid, to have here higher flexibility, and this could offer the pure hydrogen. Therefore, we are participating in the public demo project Hy4Heat, and within this, we also want to launch our first product range in 2022 with a small quantity. In response to a possible legislation change in 2025, we are aiming to launch a product range also in hydrogen readiness. Next to that, looking a bit more to Europe, we see this step coming for 2030. We're working there in parallel to prepare the certification pathway for certifying hydrogen only boilers and hydrogen ready products. Yeah? But nevertheless, we see here a certain time delay. This is simply caused by the fact that we have different situations. So especially in Europe, we have a much higher variety on gas combustion technology still in the field, where on the UK, over the time, there has already been a kind of ban of old technology that you mainly find here, modern premix combustion technology. But now coming from this quite dry picture on our plans in the future to what we actually have achieved already, and this is, I would like to hand over to my colleagues. So thank you very much for this first introduction.
Yeah, thanks a lot, Philipp, for this presentation. We have, as I had announced before, we have time for 1 or 2 questions directly related to the presentation. And the first one is, could you provide some information about the cost of the H2 ready boilers?
The cost topic is a real difficult
Philipp
thing.
is gone.
Can you hear me? I should be back.
Not sure if he will return.
I'm there actually.
Yeah, maybe Tom, can you pick up the question? What's the estimation what the H2 boilers will cost?
I think we will later on see in particular what will be the effect to the products. But let me start from this point of view. So the hydrogen ready concept itself is based on the fact that you can change, let's say, the combustion setting from pure natural gas combustion to hydrogen with just a few working steps, so saying exchanging the burner and some software parameter. Yeah? And this will, in the end, then also determine the delta cost. But it's up to now not clear whether these delta costs have to be covered by the end customer or whether it's covered then by the local distribution grid operator.
Okay, thank you. We have another question. Is there any concern regarding introducing hydrogen to an aging and then maybe also failing supply network? How long will it take to update the networks?
Yeah, this is of course a question which we as Bosch Thermotechnology cannot answer from our perspective. We can just give our position towards this. Yes, there is currently a lot of effort necessary. Yeah, definitely the grid in Europe as it is now is not fully prepared for 100% hydrogen, nor we have currently the amount of green hydrogen available. Yeah, but it's important that someone makes a start. Yeah. Otherwise, we stay in this chicken-egg circle for a much longer time. And that's why our clear strategy is to provide the gas end-use side ready for hydrogen, and then giving also the other side, so the gas supply side, the chance to upgrade grid, produce enough green hydrogen so that we are able then to use it and to start really to decarbonize that.
Okay, thank you, Philipp. So then let's now turn to the use of hydrogen in residential applications. Tom Collins will share his experiences from UK. Please go ahead, Tom.
Thank you very much, Thomas. Hello, my name is Tom Collins. I lead our work on hydrogen boilers based in the UK at Worcester. Before I go into some of the technology of hydrogen-ready appliances, I'll give you a little bit of an insight into the UK market, just reinforcing some of what Philipp's just explained to us, but with a slightly deeper focus. In the UK, the big challenge for us is existing buildings. We have a lot of very old houses, and the main technology for defossilization of heat at the moment is electric heat pumps. But in a UK home, they can present a lot of challenges to the homeowner. If you want to replace your current, probably a combination boiler with a heat pump, first of all, you have to remove a relatively small box in your living space, introduce a new box and some other large unit outside, which might cause some noise concerns. Because heat pumps operate best at low loads, you will have to reintroduce some heat storage back into the building. Many homes have lost their hot water tanks. One needs to be put back in. And also because of the low temperature requirement for the system, you probably have to replace your heat emitters. Finally, for those two reasons again, you probably have to change the way you control your appliance. Certainly in the UK, we use very sudden demands in the morning and evening, and we turn the heating off when we're not using it. So there's some degree of behavior change required. And all of these influences, plus capital outlay and some uncertainty about how a system might perform, means that despite our best efforts as Bosch to introduce heat pumps to the UK market, we've really struggled. And consumers still continue to choose boilers. This has been a pattern we've found ourselves over the decarbonize heat in the home, and we still unfortunately just sell boilers. And so the UK finds itself a little bit stuck. We can't live with gas and its emissions at the point of use, but we can't live without it at an end use level, and also with some challenges at the energy system level. This was all changed back in 2016 when a report called Leeds Citygate was published. And this was a desk study, just a theoretical study, working out if it's possible for us to convert a large city, in this case Leeds, which is in the north of England, from natural gas to hydrogen. The idea had been proposed for years beforehand, but normally dismissed almost immediately. But this report was a real game changer because it showed that actually it's feasible if you model the impact on the network, if you model the zoning of the network, if you look at the materials present in the system, actually conversion is feasible. That's partly because the UK, unlike a lot of Europe, has started replacing its iron gas mains with plastic, continuously welded polythene pipelines, and those are far more suitable for hydrogen than the old steel pipes. So an emerging proposal in the UK is to start doing these conversions in large cities, working out from industrial clusters where hydrogen would be onshored, either produced or imported. Key to this is blending. Blending doesn't just help you reduce the carbon intensity of gas early on. It also allows you to break the chicken and the egg in building large quantities of hydrogen production, because blending gives you somewhere to immediately start selling and using the hydrogen that you produce. And once you've built up enough production capacity, you can then convert a region of grid, transfer that hydrogen production capacity onto that new dedicated region, and then start again building more capacity. So blending is a real key technology to not only showing early reductions in carbon intensity, but also to allow us to break the chicken and the egg in building large scale hydrogen production. The UK iron mains replacement programme not only means that our network is very well suited for conversion, it also means that some of the costs of a hydrogen conversion are already will be dampened by what bill payers are already paying to cover this iron mains replacement programme. So the impact on bills of that Leeds project, for example, would have been just £10 a year for the end user to pay for that conversion. And it's not particularly surprising that the UK finds this a much easier prospect than other European countries. In the 1970s, we converted our entire gas distribution networks from Towns gas, which was 50% hydrogen, to the North Sea natural gas that we're using now. So in a sense, for the UK at least, switching to hydrogen is a little bit like going back again. We're going back to the future. So how do we go about this conversion, in particular in terms of the technology? Well, the UK government, when they first started consulting on this, proposed 3 different methods of converting appliances. The first was what we did back in the 1970s. We'll change a few parts in a boiler, and once those parts have been changed over, the boiler can burn the new hydrogen gas. Well, for some reasons that I'll explain to you shortly, that's not particularly possible. The next proposal was actually what was modelled in that Leeds report, which was to simply replace the boiler with a new hydrogen boiler at the point of conversion. Now, the macroeconomics of that, maybe surprisingly, are still quite attractive. But if you look at the impact on a local level, if you suddenly renew all the appliances in an area, then the small one-man and a van operations where people are currently installing and servicing and maintaining boilers, those businesses would really struggle if we suddenly renewed the population all over one summer in their local area. So not so attractive locally. The third option the UK government proposed was to build boilers that you could just convert across to hydrogen almost automatically or at the flick of a switch. And again, that's just perhaps a little bit technically optimistic at this stage. And so we had 3 ways of doing this conversion that seems like a good idea, but none of those options seem to work very well. And all credit to the UK government. When industry proposed a 4th method, they went out and reconsulted on it. And that 4th method was to build a boiler that's essentially a hydrogen boiler, but back convert it to natural gas in the factory. And then we sell it as a natural gas boiler that's hydrogen ready. That boiler can be converted just like we wanted to in the first place by just changing a few components. So hydrogen ready, that definition of hydrogen ready appliances seems to be the one that's got traction. It allows us to build the cost of the change of technology into the natural life cycle of the appliance. The parts that would be changed would probably be the burner, maybe something associated with gas mixing, and maybe some kind of coding for the boiler to know what gas it's burning. And then our life cycle replacement program just makes this look really simple. When your appliance naturally reaches its end of life, you replace it with a hydrogen ready direct like-for-like replacement appliance. And when the day comes that your gas pipes are changed over to the new gas, a few components are changed in your appliance in an operation that would perhaps take less than an hour, and your house is now burning green hydrogen. So what's inside a hydrogen ready appliance? For us, we've used our modular architecture of appliances that we have at Bosch. And so most of the boiler stays completely identical to a natural gas boiler. Where the changes happen are just in this module here, where we burn the gas and air mixture together. And inside that module, we've made a few changes, and we've faced a few interesting challenges around hydrogen. I'll take you through just a few now. The first one is how you burn the gas. So this is the burner. This is the heart of a modern pre-mixed appliance. And here is a flame. And if you look carefully, maybe look at one end of this flame, ready, steady, now, you may have noticed the flame got shorter, and you may have noticed that the burner started to glow a little bit brighter. Have another look. Look at the flames at one end. See if you can see them go shorter now. And you may have noticed that the burner deck started glowing. So what's happening here is that hydrogen has a higher flame speed than natural gas. So the flame is burning against that flow of products through the burner faster. And as you get a gas with a faster flame speed, the flames burn closer and closer to that burner surface as they're able to outstrip the speed of the gas squirting through that burner. And if we introduce much more than 23% hydrogen, as we've got here, perhaps above 50%, you would find that flame is able to propagate back through the burner. It would win the race against the flow of products through the burner, and you'd light the mixture of air and gas upstream and create a kind of pop. That's called a flashback. It's a bit like a car backfire. It's not dangerous, but it's something we have to avoid. So that's one challenge that we've overcome in our hydrogen appliances. Another really interesting challenge is how you detect a hydrogen flame. In a natural gas appliance, we detect it electrically because the flame conducts an electrical current, but hydrogen doesn't do that. Hydrogen flames are also, incidentally, almost completely invisible. And because they radiate very weakly in the infrared, the thermal band, you can't even feel the heat of a flame on the back of your hand. They are very bizarre flames to experience, but they are visible in ultraviolet. So here is an ultraviolet image of a hydrogen flame. If you want a little bit of a pub fact, hydrogen flames have an open tip. And here is, now don't worry about this, is a natural gas flame. It looks different because it's a different burner, but we can also see it in the same way. So ultraviolet is one of the range of methods we have available to still detect a hydrogen flame. So that's a couple of interesting challenges that we've been addressing in our hydrogen ready appliances. A little bit of an insight into the technology. There have been many others, and hopefully maybe in the future we'll have a chance to talk through some others. Just one final update from me, a couple of interesting insights. One is that we've discovered that the hydrogen ready appliances are remarkably low NOx. So that's a really good outcome, that we can clean up air with hydrogen as well as defossilize energy. And we've just in the UK started running a demo trial outside of our labs. So we have a boiler installed in one of these test houses, and that's been heating the house for a month and doing a great job. So we're really excited that the technology is really coming to life now and operating outside the lab. Thank you very much for your time.
from UK. We have several questions. One question has been asked repeatedly, and I will answer it. You will receive the presentations after this expert talk. We will distribute a link to the presentations to all participants. Then we have two questions related to Tom's presentation. One is, hydrogen is needed for many applications. Does it make sense to use hydrogen in heating applications?
Yeah, that's a really good question. I think the general sense is there are some areas where hydrogen is absolutely the necessary technology. So for industrial heating, hydrogen seems like, really the most attractive technology. For heavy or really long distance transport, again, hydrogen looks very attractive. And so for those applications, you'd really say those are priority hydrogen applications. Probably also for filling the place that gas currently plays in electricity generation, hydrogen offers a really good way of providing that dispatchable electricity generation. So heat probably sits, domestic heat or building heat probably sits kind of fairly close to the bottom of that heap of priorities for hydrogen. But it is a really key technology to enable that transition to happen quickly and effectively. If you can upgrade most UK properties to be able to be heated with a heat pump, but the cost and the invasiveness and the space impact would seem very unfeasible to people. It could cost tens of thousands of pounds to improve the building fabric of some of these older houses. The capital outlay for the technology itself is high compared to alternatives. The space requirements inside the house are a real problem in the UK, where we live in small homes, and our user behavior, the user insights research that's being done in academia now is showing that people are very attached to their lifestyle and very unwilling to compromise the way they behave or the way they use heat to adapt to a new technology. And so if we want this transition to happen quickly, and we want a really resilient energy system at the end, where we're not relying on a kind of a single vector for everything, then it makes lots and lots of sense for us to have hydrogen in the mix for heat. And so I'm always challenging the argument where people say, is it electrification or is it hydrogen? That's the wrong question. The answer is, how do we integrate the two? Because they both need to play a part. They both have a role to play. Without either of them, we're unlikely to succeed in our mission.
Okay, thank you. There's another question. How does hydrogen affect the efficiency of a boiler? Is there any difference when using hydrogen instead of natural gas?
Yeah, okay. Yeah, thanks, Thomas. That's another very good question. The physics of the heat transfer is really, really similar. Hydrogen combustion products are very similar in their properties to natural gas combustion products. There's just no CO2. The flame temperature is very similar. There's slight differences in condensing, but what we find is that the thermal performance is very, very, very similar indeed. And actually, what has a bigger impact on the measured efficiency is the way we calculate the energy value of the fuel, which is based on a reference value of 15 degrees C. And that means that when you test the efficiency of an appliance, and you've got the coolest temperature available in those tests is normally 30 degrees C, there's some lump of heat that's counted as being available energy in the gas by the way we calculate the gas's calorific value, but is not physically available to a boiler to recover. And how big a lump proportion of the gas's energy is in that unrecoverable lump has an impact on the efficiency. And when we're looking at individual points of efficiency, that's the most dominant effect. So the boilers perform the same way. Their efficiency on the label will be slightly different. That's as much to do with the way we calculate the energy value of the fuel as the way they perform. The thermodynamics is very similar. So, okay, long, complicated answer. The simple version is their efficiency is really, really similar.
Okay, thanks a lot, Tom, for your contribution. Another important area of hydrogen usage is in commercial and industrial applications. Daniel Gosse will now elaborate on this topic, and Daniel, the floor is yours.
So, hello, share my screen. This should work right now. Perfect. Yeah, thank you everybody for participation today. Let me perhaps introduce myself. My name is Daniel Gosse, head of the Industrial Boiler Academy And today I will talk to you about the use of hydrogen in commercial and industrial heat applications, because we have already a few years of experience and some knowledge that we will also use, of course, in our residential applications. So that helps us introducing these new technologies. When we look at commercial or industrial applications, what are they used for? I think everybody of you maybe has had breakfast and has had a sip of milk in his coffee or whatsoever, or eaten some bread. All of these things, also maybe the tires of your car, everything of this is produced and using heat during production. And the difference to the heating applications is that there oftentimes we need higher temperatures than for heating, meaning if we look, for example, at a brewery, typical temperatures are 180 degrees, but there are also many applications with up to 300 degrees Celsius. When we look at decarbonization, defossilization, then we must acknowledge that about 45% of primary energy consumption, for example, in Germany, are happening from the CO2 emissions result from commercial industrial applications. And half of the energy they are using is for thermal processes, 53% to be exact. And that means that there is a large potential of CO2 emission reduction. But there are also challenges, because I'm often asked the same question as Tom, what is it, hydrogen or electrification? I always have to say it will be both, in my opinion, but hydrogen will play an important role, because you can store it much better and in higher power density than electric energy, and also it will be available from storage when there is no wind blowing and there's no sun shining. So therefore, in my opinion, we will see a mix of the different renewable energy sources, and hydrogen, due to its storability, will be very crucial. In this case, also often the question is asked, why don't you use heat pumps for high temperature applications? The problem with those is that we are limited in the temperature range. So there are very few high temperature heat pumps, and they require actually a high temperature waste heat source. So when I have a heat pump that can manage 50 Kelvin temperature hub, then, for example, if I want to achieve 300 degrees, I need 250 degrees of waste heat available. Who has this? And the other problem is you need then special refrigerants and eventually multi-stage heat pumps. So in this case, electrification for the large systems in the high temperature range rather relies on direct electric energy use. And this is, of course, very expensive as a primary energy source. Therefore, combustion will remain, in my opinion, a very important aspect, and green hydrogen as well as biofuels will take part in this. The problem, of course, with the biofuels is the limited availability, so scalability, because, of course, we are feeding more and more people on this globe, and therefore we will rather grow food than energy on the fields when we have alternatives with, for example, solar or wind energy to create hydrogen. So let us look a little bit in the technical details. What's the differences? Before, I will show you some practical applications where we are using hydrogen already with 100% in several factories and district heating applications. The really cool thing about hydrogen is if you burn it, you don't create CO2, but there is water resulting as flue gas. That's a really cool thing. What you have to look at is the volumetric heating value. So hydrogen has a very high energy density if you look at the weight, so per kilogram. But if you look at the volume, it's only 1/3 of natural gas, meaning no problem. We just need to put through 3 times as much volume of gas if we use it in a gas form, what we are doing in the gas grids. The flame temperature is a little bit higher, therefore we need to take measures to take care that there is no additional thermal NOx resulting, but there are several technologies available. For example, flue gas recirculation, or as Tom just showed, surface burners, with which we can achieve really good future-proof values and have a very, very clean flue gas of pure water steam. Nevertheless, also hydrogen is burning a little bit quicker than natural gas. We already saw this in the flame that was coming closer to the burner. Therefore, we need soft ignition measures. Also, we are using for hydrogen flame protection devices, meaning that can avoid a flame going backwards into the system. We didn't see any of these happening, but nevertheless, we have it as a precaution because it's a new technology, and for Bosch, safety is crucial and important. Also, hydrogen diffuses through metal. We just heard this for the steel pipes of the gas grid. Therefore, we need to use special materials in the gas ramps and also take care. For example, if you use stainless steel, there hydrogen can create embrittlement, so weakening of the material. Therefore, we use, of course, hydrogen certified materials. What are we offering at the moment commercial and industrial customers? That is, on the one hand, hydrogen firing. But of course, as you know, not everybody has 100% hydrogen, especially when it goes to the megawatt range. But what are we doing technologically there in the product? We are oversizing the boiler and the combustion part because I told you, you need higher throughput of gas and air. And to achieve this, we oversized the boiler body. We have a little bit stronger fan blowers on the burner. And mostly we install an external recirculation because for the very large boilers, it's difficult to implement a surface burner. But many customers already tell us, I have now natural gas available. I know I will have hydrogen in the future, but now I'm installing a boiler and I will operate it for 30 years. I need to be future-proof. What can I do? In this case, we are offering hydrogen-ready boilers to the customers, meaning the boiler and the combustion dimensioning, combustion part of the boiler, are already suitable for hydrogen up to 100%. And then we equip it with a multi-fuel burner, for example. There was a question regarding prices before. For the big industrial boilers, you can say the burner for 100% hydrogen combustion is about double the price of a natural gas burner. And the boiler body, 10% bigger, means about 10% higher price for the boiler itself. But be aware, if you want to introduce more than 10% of hydrogen into these products, then you need a new CE certification. But these are individual products. Each boiler is produced only one single time, and therefore this is no problem. I promised you to show some practical applications. This is one of our first hydrogen projects that we had. It's a pharmaceutical company in Switzerland and runs a 20 ton per hour steam boiler with 30 bar. And for this company, reliability is key. Therefore, they have multi-fuel burner that can operate with natural gas, 100% hydrogen, which they receive from processes. So in this case, it's, to be honest, no green hydrogen. And as a third backup, they even have light oil. But that is only as a worst case backup in case there should be no hydrogen, should be a problem in the entire gas grid of this area. And they are running a process at the moment because they would lose lots of money if they wouldn't have process heat available and would have to dispose what they are currently producing. Therefore, in this case, triple fuel, very special solution. Let me give you another example. This is district heating example from Germany. The municipality of Untitled is there erecting a 10 megawatt green hydrogen electrolysis machine together with Siemens, and they are installing a district heating boiler that's also used for commercial applications for drying wood. And in this case, they have a 5 megawatt boiler, and they can implement the hydrogen not just for this boiler, but also, of course, for mobility and other users. But of course, the boiler there is a very good application to use the additional hydrogen that they can't use in other applications. So they gain lots of temporary flexibility on managing their resources. last but not least, in this case in Russia, chemical industry, another steam boiler, no heating boiler, and in this case also waste hydrogen from processes. And this company then runs also multi-fuel burner and has priority on the hydrogen because for them it's free energy that they receive, and they are mixing it flexibly and again using exhaust gas recirculation in order to have future-proof emission values. And by using condensing technology, they even maximize their efficiency. This question was asked before. So in this case, they even get the enthalpy from the water that is created back by turning it from gas to a fluid version. And yeah, that was also for us a very important project to gain some experience also on the blending. How do you ignite hydrogen in a very safe way? So we learned a lot and now are looking forward to having more projects also with green hydrogen. There are some pilot projects running at the moment. Let's see which of them are realized. Nevertheless, at the end, hydrogen won't be the only answer. In my opinion, it will be a mix. We will see hybrid solutions with electric direct energy use, also together with hydrogen or, for example, biofuels, biogases. And of course, we will also see CO2 optimization of existing boilers and upgrades of existing boilers to CO2 neutral fuels. And that altogether will play an important role in the, in my opinion, already close future. Thank you very much.
On a technical question, is also excess heat from the electrolyzer used in the use cases you have shown?
In this case, no, because the necessary energy level that is used is not achieved.
Okay. And the second question is, why is it attractive to use hydrogen in the industrial applications when you consider efficiency all over the whole supply chain from generation to usage?
Yeah, that is something that is often forgotten. When I convert green electricity into hydrogen, I already lose somewhat 30% of efficiency. And but what is the problem? If I have green energy that is for free and I have more than I can use, then why shouldn't I put it into creating hydrogen that allows me flexible use later? So therefore, also in my opinion, in many industrial applications, we will see hybrid boilers, as I just have shown, with an electric heating coil that is used when there is green electricity available and at night and when there is no wind. Then additionally, we will use the hydrogen. So this, I think, is the best solution that integrates in the total usage of hydrogen.
Okay, thank you. I try to cluster the questions a little bit so that we can cover most of them in the remaining time. And there are 5 clusters that I would like to address. The first one maybe goes to Philipp. It's a question that has been asked several times. When will we have enough hydrogen and a distribution network to cover all the demand that we've seen here and that we also have in other lines of industry?
This is a very difficult question to answer. So what we know right now is that there is a lot of activity on the governments, mainly in the European Union. Yeah, so you maybe have heard in the latest days that also Portugal now wants to be the supplier of green hydrogen for Europe. Yeah, and there are a lot of activities ongoing, like building up a hydrogen backbone, European Hydrogen Alliance. Yeah, all this are very good and very important steps to come to the availability of hydrogen at the gas end use side. Yeah? But it's very difficult to exactly predict. The only dates we clearly have for us as strategic goals are the 2025 date for this potential legislation change in the UK, and then jumping to Europe, the 2030 date, which we currently see as realistic in the industry.
Okay, thank you. There are two questions related to the residential boilers, I would say. That means I will address them to Tom. First one, is the maintenance of a hydrogen boiler different from a natural gas boiler?
No, they'd be very, very similar. When we developed our appliance, we looked really widely for technologies for burning hydrogen. So we were ready for our appliance to look really different. But as it turns out, and probably unsurprisingly, the best solutions are very, very similar to the ones we use now. And in fact, we're using the same heat cell that you'd use in a natural gas boiler. Many other components are also absolutely identical. So a hydrogen boiler feels and looks just like an existing natural gas boiler to service and to maintain. There's no difference.
Okay. And the second one is, what about NOx emissions in hydrogen boilers? Is there any difference in nitrogen oxide emissions?
Okay, so there's a distinction to be made here between appliances with pre-mixed burners and appliances with diffusion burners. In appliances with diffusion burners, the flame temperature impact of hydrogen is bigger, and we have to build in measures to mitigate that potential increase in NOx. So there's a job to be done there. In pre-mixed burners, which are the ones you find in domestic and the smaller commercial appliances, it seems that so far everyone's getting kind of inherently low NOx out of those appliances. So our appliance already meets London's ultra low NOx limits, and that's before we've even gone to town trying to improve it. So certainly for pre-mixed domestic appliances, hydrogen's really great news for NOx. And in the larger appliances, it's one of those pieces of engineering that we're going to have to tackle head on. But there's a wide range of mechanisms available to do that, so it's not a blocker.
Okay, thank you. And there have been several questions about price levels, Philipp. On the one hand, what should be an attractive price level for hydrogen itself? What might be an attractive price level for the boilers? Can you say?
This is a very nice question, and there's one clear task we as Bosch want to address to the governments here, and this is the topic social equity. What for sure will not work is that in the end customer will pay more for burning hydrogen, and having then a certain decarbonization effect, while the other one will have the lower energy cost. So here we clearly ask for regulation, and this can go in the direction of a certain CO2 pricing, or it can go into a certain benefit to the end customer, that if customers then making actively the choice for hydrogen or hydrogen ready products, that they then get a certain benefit like subsidies. In the end, the target must be clear. It needs to be social equity. So we cannot leave anyone behind.
Okay, thank you. So let me see. I think we covered at least all the clusters. Let's check in the chat. No new questions. So I would say there's some time left, but we do not have to fill it completely. The 60 minutes are almost over, and we have to come to an end. As I said before, we will distribute a link with the slides to all participants. And then I can simply say thank you to all who joined today. Thank you for your questions. Thank you to the presenters. And the next episode of this Expert Talk series will take place on December the 15th. And the topic will be carbon neutrality at Bosch Termotehnică. So thanks a lot. Stay healthy. Bye-bye. Take care.
Thank you very much. Goodbye.
Have a good day.